occur. Let us understand lattice energy and Born-Haber cycle. With the help of Born-Haber cycle, which was devised by Born and Haber in 1919, we can relate lattice energy with other thermochemical data involved in formation of a lattice. Lattice energy is the amount of energy which is released when 1 mole of solid ionic compound is formed from its constituents. When ionic compound is formed, it has a cation in it and it has an anion. And if this crystal lattice is stable, then there should be minimization of energy of the system. Hence, energy should be released out of this reaction. To understand this, the energy terms involved in building crystal lattice of a sodium chloride may be taken in various steps. The elements in their standard state are first converted to gaseous atoms and then to ions, and finally they will be packed into crystal lattice. First step involved here will be sublimation of sodium from solid state. It will go to gaseous state. As energy needs to be supplied for this reaction, the energy of the system will increase. This energy, also known as enthalpy of sublimation, is 108.4 kilojoules per mole. Next step will be ionization of sodium to sodium cation. Again, ionization energy for sodium to sodium plus is around 495.4 kilojoules per mole. Here also the energy needs to be supplied to the system as electron needs to be removed from the valence shell. Now we need to dissociate this chlorine molecule to chlorine atom. The energy involved here is also a positive term, as energy needs to be supplied to dissociate this chlorine molecule, and the enthalpy of dissociation is 120.9 kilojoules per mole. Now we have sodium cation, chlorine atom and an electron in the system. So next step will be chlorine will get converted to chloride, and this is known as electron affinity, and this energy we consider it to be negative because energy will be released from the system when electron combine with chlorine atom to form chloride ion. This energy for chloride ion is around this energy change is around minus 348.6 kilojoules per mole. If sodium chloride crystal is formed from sodium cation and chloride anion, further there will be decrease in the energy, and this energy is known as lattice energy. As according to the definition of lattice energy, it is the energy released when 1 mole of solid ionic compound is formed from its gaseous constituents. So there is a cation, there is an anion in a gaseous state, and they combine to form sodium chloride, releasing energy into the universe. According to Hayes' law, the overall energy change in the process is equal to delta HF, that is the enthalpy of formation of sodium chloride solid from sodium atom and chlorine molecule, is sum of enthalpy of sublimation of sodium, enthalpy of ionization of sodium, enthalpy of dissociation of chlorine molecule, electron affinity of chlorine atom, and finally formation of the crystal lattice, that is the lattice energy. All the terms here can be measured experimentally than electron affinity and lattice energy. Originally, this method was used to calculate electron affinities of electronegative elements. Now, from the known crystal structures, it is possible to calculate lattice energy. This figure is not to scale. Further information you can get it from Shiver and Atkins Inorganic Chemistry, Principles of Structure and Reactivity, Concise Inorganic Chemistry or Solid State Chemistry and its Application by Anthony R. West. देव बरे करो.